Oh my God! Look at this nice, wonderful tree. I think I just want to sit by it. Okay. Ah! Assistant? Wait a second, how was that tree running? Oh hey there, my name is Albert Einstein, and what you just saw was gravity. For simple terms, it's a true, attractive force that acts between the bodies no matter how big or small. For example, if you throw this apple in the air, it falls. Well wait, where is this sound coming from?
Life is brilliant.
Whoa! Gravitation is not responsible for people falling in love. Well, now that's over with, I'm gonna tell you about the 3 greatest scientists. Thomas Graham, Sorensen, and me, Albert Einstein.
Wait, but what about me?
And you are?
Admit you ran away.
Mother! Beep! Hello, my name is Albert Einstein, and I'm here to tell you about special relativity and a bit about general relativity. But first, let me tell you a little bit about myself. I was born on March 14th, 1879 in Wittenberg, Germany, and died on April 18th, 1955. I received a Nobel Prize at 1921 for my services to theoretical physics and especially for the discovery of the law of photoelectric effects. I am also known as the father of modern physics. You may have also heard me in the Manhattan Project, which was when I had to create a nuclear bomb with nuclear fusion. My famous quote is E equals mc squared, which is mass energy equivalence. Now enough of this shenanigans. I am here to tell you about special relativity. Special relativity is a physical theory of measurements and inertial frame of reference proposed by me in the 1905. Special relativity generalizes Galileo's principle of relativity, that is, all uniform motion is relative, and that there is no absolute and well-defined state of rest of mechanics to all laws of physics, including both of the laws of mechanics and electrodynamics, whatever they may be. Special relativity also incorporates the principle of the speed of light that is the same for all inertial observers, regardless of the state of motion of the source.
Go!
This theory has a wide range of consequences which have been experimentally verified, including the counterintuitive ones such as length contraction, time dilation, and relative to simultaneity, contradicting the classical notion of the duration of the time interval between the two events is equal for all observers. Combined with the laws of physics, the two postulates of the special relativity predict the equivalence of matter and energy, as expressed as mass energy equivalence formula E equals mc squared, where c is the speed of light in a vacuum. The predictions of the special relativity agree with the Newtonian mechanics in the common realm of applicability, specifically in the experiments in which all velocities are small compared with the speed of light. Special relativity reveals that c is not only the velocity of a common phenomenon, namely the propagation of the electromagnetic radiation which is light, but rather than the fundamental feature of the way space and time are uniform as space-time. One of the consequences of the theory is that it is impossible for any particle that has rest mass to be accelerated to the speed of light. The theory was originally termed special because it applied to the principle of relativity only to the special case of inertial reference frames. For example, frames of reference in uniform related motion with respect to each other. I even developed a general relativity to apply the principle in the more general case, that is, to any frame so as to handle general coordinates transformations, and that theory includes the effect of gravity. The term is currently used more than generally to refer to any case in which gravitation is not significant. General relativity is a generalization of the special relativity to include gravitation. In general relativity, gravity is described as non-Euclidean geometry, so the gravitational effects are represented to the curvature of space-time. Special relativity is restricted to flat space-time. The curvature of the Earth's surface is not noticeable in everyday life. The curvature of space-time is neglected to small scales. So locally, special relativity is a valid approximation of the general relativity. Well, my story is over now. Time for Sorensen.
Hello, my name is Soren Sorensen. I was born in January of 1868. Growing up, school was the most important thing in my life. When I started college, I wanted to study medicines. However, later on, chemistry started to interest me the most. After graduating school with a Master of Science degree, I started an interest in proteins and amino acids, but that was before the real work began, before my PhD. It started when I was examining the process of determining hydrogen ion concentration. This method is called the electromotive force method. Determining hydrogen ion concentration is to determine how many hydrogen ions there are per cubic decimeter. This process led me to see that the number of ions can determine the acidity or alkalinity of a mixture or solution. After this discovery, I put the acidity and alkalinity of a liquid to the test. I created a scale, the pH scale, which simplified the process of determining the hydrogen ion count. I took the acids and bases and synthesized them. Using the pH scale, I could see the acidity or alkalinity in the liquid. If the liquid was 7 on the scale, it was a neutral liquid. Anything above 7 has increasing alkalinity, and anything below 7 is increasing acidity. Alright, I'm done. Now it's time for Thomas Graham. Hello, my name is Thomas Graham. I was born on December 21st, 1805 in Glasgow, Scotland, and when I was 14 I entered the University of Glasgow. Anyway, in 1831 I came up with a law I named after myself, Graham's Law of Diffusion. This states that the rate of diffusion of gas is inversely proportional to the square root of the mass of its particles, which is written as rate 1 over rate 2 is equal to the square root of m2 over m1. My research of diffusion of gases was triggered by reading about the observations of a German chemist named Johann Dobereiner. Johann stated that hydrogen gas diffused out of a small crack in a glass bottle faster than the surrounding air diffused into to replace it. My research of diffusion of gases was triggered by reading about the observations of a German chemist named Johann Dobereiner. Johann stated that hydrogen gas diffused out of a small crack in a glass bottle faster than the surrounding air diffused into to replace it. My discovery of colloids is what eventually led to my discovery of dialysis, which is still used to this day in many medical facilities. Dialysis is the process of removing excess water and waste from the blood, usually for people with renal failure. In 1841, I founded the Chemical Society of London and was elected a member of the Royal Swedish Academy of Sciences in 1856. I then died at the age of 64 on September 16, 1869. Now it's time for Dmitry Mendeleev.
I need to get a drink. Wait a second. There's a table of elements. Oh my god, I need to create a periodic table of elements! Hello, I'm Dmitry Mendeleev, and I was born on 8th February 1834 in Verkhny Armziani, Russian Empire, and died on 2nd February 1907 when I was 72 years old in St. Petersburg, Russian Empire. I'm known for creating the periodic table of elements. My other achievements are creating the smokeless powder, which name is pyrocolodion, and I contributed to the Russian Navy, but it didn't get famous. Also, I introduced the metric system into Russian Empire. On March 6, 1869, I made a formal presentation to the Russian
chemical society. It was about the elements, you know, independence of elements between the properties of the weights of the elements. Anyway, 8 points that I presented to the society made me the father of the table of elements, because also there was this Meyer person who, like, after a month after I created the periodic table of elements, he was like, oh look, I created the periodic table of elements. But because I actually did this before him, they counted me. The elements, if arranged according to their atomic mass weight, exhibit an apparent periodicity of properties. Elements which are similar in regards to their chemical properties have atomic weights which are nearly the same value, or which increase regularly. The arrangement of elements in groups of elements in order of their atomic weights corresponds to their so-called valencies, as well as to some extent to their distinctive chemical properties, as is apparent among other series in that of Li, Be, B, C, and O, and F. The elements which are most widely diffused have small atomic weights. The magnitude of the atomic weight determines the character of the element, just as the magnitude of the molecule determines the character of a compound body. Point number 6. We must expect the discovery of many yet unknown elements. For example, 2 elements analogous to aluminum and silicon, whose atomic weights would be between 65 and 75.
2, 1.
Point 7, which I presented to the Russian Chemical Society, stated the atomic weight of an element may sometimes be amended by a knowledge of those of its continuous elements. Thus, the atomic weight of tellurium must be between 123 and 126, and cannot be 128. Certain characteristic properties of elements can be foretold from their atomic weights. Points that I said, I'm not saying all of those points that I say were correct, but that's what the points were. And now for a short movie.